Okay, so what have we done? Well, let's just review what we did. We had an operating system, XP. We had it in a start state. We could also call it a snapshot. And that would be represented by the file 1.gene.cache. Okay, so as changes were made, they were stored into the cache file. We then performed some actions. For example, we created a folder and a file, etc. And then we captured the end state, which is represented by 2.gene.cache. And then we were able to compare the files and the start versus the end state, so we could see what changes had been made. So what have we learned? Well, we saw that some of the changes were unrelated to our actions. For example, there's Windows software downloads, there's Windows logs, security and other logs, and there's Windows backup. So these processes tend to happen continuously. Now, you should get to know these. And you should make sure to understand them so you can sort of eliminate those from your inquiries. But some changes were actually related to our actions. For example, we could even see the newly created folder and file. So, we created a folder and file. We discovered a recent directory contains .link files, which pointed to that folder and file. And we saw that the index.dat file contained a reference to our file. It wasn't just a reference either. It had the name of the user and it had the time. But you might say those artifacts, namely index.dat and the recent folder, gave us no more knowledge than the folder and the file themselves. And that is nearly true. With the folder, you had the last modify time. So you know when it was created, and the file itself had a last modify time. So you know when that was last modified. Okay. However, the artifacts do give us extra timestamps. For example, the file was visited when you double-clicked on it to access it, when you double-clicked on it to start Notepad. And that time would be the time when Notepad was started. Whereas when you saved it, that was the time of the last modify date. So this can give us extra information. We know maybe how long the file was open. So these can be useful. Also, these artifacts can be used to detect anti-forensics. So say somebody doesn't know about these artifacts and they think, oh, I better pretend that that folder was changed recently. And so they might use a tool or something to change the times on the folder and the file. So it looks as if those files were created maybe a week beforehand. But you still have the index.dat and the recent folder, which tells you, gives you information about when they were accessed and when they were used. Okay, not only that, if you are simply accessing a file, so let's say there's a file you didn't create, but you're trying to access that, then you need the last modify time will not change, so you need some more information. And you can get that information from these. They tell you that this file was accessed at this point, and there's some other information you get as well. Now, a second objection might be, this is XP. This is like ages ago. Why are we interested in this? Well, we're not particularly interested. It just happened to be the image that I was looking at. But these techniques can be applied to any operating system. It could be applied to, obviously, Windows 7, any of the Windows 10. But it could even be applied to the Mac. We haven't used anything specific to Windows. And any version of Mac OS, you could use it for Linux as well if you wanted to observe what was happening. You just simply start, you get your disk image, you start it in a virtual machine, you save the state, you perform some actions, and then you can see exactly what was happening. So this is a very powerful and a very general technique. Okay, now, so far we've just looked at the files and whether they appeared or disappeared. When we had a list of files and we looked at the difference, so we could see whether a file appeared or disappeared. However, some files might have been there both times, but they might have actually been changed. So we would like to detect that. So how would we do that? Well, we can convert the states into a file system as we did before, but this time instead of just printing the file name, we also print the last modified time. So that means that if they did change, now we will be able to spot that, and we'll be able to see how those have changed, and we'll see what new information we can learn. Okay, well, how would you do that? Well, the last time we used the find command, and we just had find and the name of the directory. But you can do other things with the find command. Rather than, if you do nothing, as we did before, it just prints the name of the file. Now, this might look a bit scary. I'm not sure how used to you are to Linux, but this is actually, again, it's just a matter of getting used to it. As if you play around with this for a while, it becomes very natural. But these three characters here basically mean print the time. Now, print the time before the file, because the time is always a fixed size. And it actually looks very messy because these keep changing in size, and so it'll look very messy if we don't. So just print the time, there's a space then, and the %p means the file name. Okay, so this is going to be the last modified time, this is going to be the file name, and /n just means a new line. So if I run that, it will print a list. Much simpler if you see that demoed, so I'm going to do that next.